Welcome, everybody. Thank you for joining us. For those of us in the Seattle area, we seem to have snow coming down here, but hopefully the rest of you are better off. This expert forum follows the one that we had in January, particularly bringing together those who are doing monitoring around deployed devices. And as some of the feedback we had on that last forum, there were a number of topics that were of real interest to people. One of them was this whole issue of standardization of data collection, whether to do it, how far to go with it, etc. And that's the topic of today's interaction. We received slides from a few people, not very many, but that doesn't matter. We can sort of cover the topics we want to. As I mentioned a minute ago, we lost several of our marine mammal and seabird monitoring researchers out of the UK because there was a sudden call and all hands on deck with the last of the Maygen turbines going in the water. And there was a whole group of people asked to be up there, so they won't be joining us today. So what we're going to do is start talking about fish monitoring and then get to marine mammals sort of by popular demand, as it were. What I'd like to do, though, first is have people go around on the phone and tell us who's available or who's with us today. Here in the Seattle office at PNNL, we have Andrea Copping, Jonathan Whiting, Michaela Freeman, and Amy Woodbury. So if people want to go ahead and introduce themselves.
Garrett Staines from PNNL at the Marine Sciences Laboratory.
You've got Melissa Oldreeve and Tyler Boucher here from FORCE.
Danielle Rio is on the line from NOAA.
This is Karis Burgess from Cape Sharp Tidal.
This is Jason Wood with SMRU Consulting.
Anna Redden from Acadia.
Nate Johnson from ORPC.
Samantha Eves from U.S. Department of Energy.
This is Sherry at PNNL.
Yeah. Gail Zidleski and Aurelie Daru from UMaine.
I'm Hans Sørensen from Waydragon in Copenhagen, Denmark.
Okay, wonderful. Thank you. Okay, so we're going to go ahead here. As I said, the topic today really is standardization of data we collect around turbines and WECs, so we are dealing largely with tidal turbines in this group. We, as far as what we're going to do today, I guess I'm going to sort of drive things here, and we received sets of slides from these people listed here. Aurelie, Melissa, and Haley in the Bay of Fundy. Also Haley talking about fish interactions around turbines. Haley also has some information on the FAST platform. And Gail, Garrett, and Haley also from the University of Maine. Haley does seem to turn up a lot. So what we're going to do is I'm going to ask, I don't know if it's Aurelie or Melissa, to go ahead with the first set of slides and just talk a little bit about what they are doing for monitoring around the turbines in the Bay of Fundy. And then we'll sort of move on from there and move into some discussion of how data are or are not being collected in the standardized format and what we really need to do as a community about it.
So my name is Melissa Oldreeve. I work with FORCE running the environmental monitoring program. I really will hand it over to Aurelie and then to Haley, but just to say, with a deployed tidal turbine at the site by Cape Sharp Tidal, FORCE is looking at fish, marine mammals, lobster, seabirds, and then the impacts of marine noise. And we also have a program which Haley is going to talk about called our Fundy Advanced Sensor Technology Platform, or FAST. Both of these are about innovation and environmental monitoring and learning about our site while simultaneously learning about the equipment and the data that we collect there. The University of Maine and Aurelie have been leading our fish environmental effects monitoring program from 2016 and into this year. So maybe I'd leave it to Aurelie to get into that in more detail.
Yeah, so basically we are doing like mobile hydroacoustic survey.
So we are using a new EK80 echo sounder, which is a large band echo sounder. But for the most part of our recording, we are using only one frequency, which is 120 kilohertz, because we want to stay consistent with baseline data, which was collated at 120 kilohertz. You can go to the next slide. I will try to stay quick. So our sampling is at the fourth site, so in Nova Scotia. So we are trying to have a good coverage of the impact area. We have like 6 transects in the impact area, which are 1.8 kilometer long and 100 meters apart. We are doing each transect twice, against and with the tide, but we are also sampling a control area, and we really want to like push on these ideas that having a control area and sampling not only where the turbine is, but also in another area which can be set as a control is really important, and we should really continue to do it. Our surveys last 24 hours. It's mainly to cover 2 ebb tide and 2 flood tides, but also to have day and night data. That's also important to have night data. We know behavior of fish are really different between day and night, so having both like sampling is also something important. And we are also sampling, we are trying to sample every month, and it's always at neap tides.
And some of that is informed by some of the work that Haley did over a long temporal time series in terms of knowing fluctuations of fish and variation in their presence over time. And then I just want to, this is Gail Zidleski. One of the other things that, for those who aren't familiar with the site, the impact area there is the site where Force has 5 berths for turbine developers to put in turbines. And right now there's 1 that's deployed there. And so the work that we started here started before that turbine went in, and now there's 1 in there with the intention of multiple down the line. And I don't know if you want to add to that, Melissa.
No, I think that was pretty accurate.
And the other thing that Orally mentioned was baseline data. So Gary Melvin from Department of Fisheries and Oceans had collected data at this site some time ago, and so we're trying to keep the methods that we're using somewhat consistent with his data collection. So, speaking back to the standardization may be difficult because we want to be able to make sure we could take advantage of as much data as possible, including the baseline data to compare back to. So I'll turn it back to Laura. I'm sorry.
I think I finished with this slide. You can go to the next one. Thanks.
Excuse me, this is Sherry. I have a question about the temporal sampling there, just to be clear. So how many, so you're doing 4 surveys every 24 hours, was that?
No, it's one survey of 24 hours, and we are trying to sample every month. It's not really every month, it's basically January, March, April, May, there is nothing in July, August, September we didn't do it, there were November, so it's like more, I would say 8 to 10 times a year.
And the survey is a continuous 24-hour survey, but you're doing essentially the entire impact area during a day flood tide and a day ebb tide and a night ebb and flood tide. Does that make sense?
Gotcha. Okay. Yeah. Thank you for that clarification.
Mm-hmm.
So all this acoustic data are processed using EcoView, and we are exporting from this software the relative fish density and about standardization to only detect fish and not taking into account any zooplankton. We are using a target strength threshold of minus 60 decibel. And so after all these really fish density numbers are used to study the rudder column relative fish density, but also the vertical distribution of fish. And so Ailey, Gail, and Garrett worked in a probability of encounter model, and we will try also to use it on those data to determine what is the probability of the fish being at the same depth of the deployed turbine. So that's all. I will say really quick. I think there is lots of people who need to talk.
So are there any other questions about what we've heard so far, or should we go ahead, because Haley's FAST platform really follows up on this, doesn't it?
This is Sherry. So just to summarize, since the topic here is data standardization, so the data that you're using is just the vertical distribution of the fish.
It's also total relative density over a transect.
Oh, okay.
Mm-hmm. So and vertical distribution. So you can integrate over an entire transect the relative density of fish. And then the second piece to that is you could look at each bin of the water column, essentially how we've been dividing it into 1 meter bins, and look at where are fish in the water column vertically.
Okay, great. Thank you.
Okay, Haley, do you want to go ahead? We get the next slide up, please.
This is again the foresight that Gail and Aurelie just talked about, zoomed in on the control area that they were sampling. On the right here, you can see the platform that we're using, and so what we're doing here is kind of instead of the spatial coverage that Gail and Aurelie are getting with their kind of running laps of that area, we're putting this platform down on the seafloor that's stationary, and it's looking straight up from the bottom instead of down from the top, but again looking at the vertical distribution of fish over time at the site. And for now, so far what we've collected, if you look on the map there, there's a little triangle way out in the corner of the Crown Lease area that says FAST 1. One of our echo sounders is the AZFP, the Acoustic Zooplankton and Fish Profiler. It's the one in blue there. And it was deployed on a separate platform there and also a little bit farther in for 2 months so far. And recently we've completely outfitted this platform that you see here with that echo sounder, also an EK80, and planning on running that with multiple frequencies for short periods of time and just one frequency for a little bit longer, as we duty cycle through all of these pieces of equipment. We also have an ADCP on this platform, so measuring current speed, and we have an Anthera, which is a little thing that measures things like, I think, near-field turbulence and oxygen, things like that. And we'll get to that in a second. But these are all on this one platform now, which is currently deployed where the little diamond is in the map for a test run. We're getting that back next week, and then it will be deployed out on the Crown Lease area, somewhere kind of in that black dash circle, we think. But we're still kind of going to be targeting the exact location. And that's going to be 4 times a year approximately for at least a month every time, and we're targeting spring, summer, fall, and winter. Can we go to the next slide, please? So here are the data that we're hoping to get that we will get and have gotten from that platform. This is an example of information on the bottom here from the AZFP. You can see it's just a vertical profile of the water column, and what we're looking at is volume backscatter, so that relative metric of fish density over time. With the EK80, we can start getting at target strength, so in some ways you can equate that to fish size, but it's pretty rough. We're getting current velocity at the same time from our ADCP. We get temperature, pressure, conductivity, oxygen, and tilt roll of the platform. Again, we're trying to spread these out over the course of a year, sampling multiple times per second when we are sampling. And we're still determining the duty cycle, but it will be some amount of minutes per, say per hour or something over the whole course of the deployment. All of the data are saved. What we're hoping for is basically high-resolution, long-term time series of vertical distribution and relative density. If you go to the next slide, please. Here you can see just an example of that. So this is a very preliminary assessment from 1 month of the data we've collected so far, just looking at the vertical distribution of fish. And the idea is look at the vertical distribution, look at how it changes over time, and similarly to what Aurelie and Gail said, kind of work that into an estimate of the probability that fish might encounter a turbine based on depth. And I think this could be integrated well with the spatial information that Gail and Aurelie are currently getting at the site as well. I think that's pretty much it. I think the eventual goal with these types of data is to work it into some sort of population level effect model, and that's something we're stretching for at the moment that we need to work on. I think that's it for me.
Great, thanks, Haley. Questions for Haley? Actually, Haley, this is Andrea. I have one. You are planning on keeping all the data you are collecting on board. Are you not concerned about the amount of data? Have you, is this, wait a second, this is cabled, right?
No, this is free.
Not cabled, so you,
yeah.
so you may have a data storage and data dump issue.
So, yeah, that's something to consider. That's partially why we'll, basically the length of the deployment is limited by your battery life and the storage space.
Yeah.
So we're going to be looking into what's the best duty cycle that we can do that will give us the longest deployment with the storage space that we have available. We think we can get at least a month, and we'll achieve that. It won't be running necessarily continuous. So far, it's been out there just running continuously, and the AZFP data is quite small, so it can go a long time.
Oh, okay.
The EK80 file sizes are larger, but we'll be working on ways to bring that down. I think the best way will be the duty cycle, so a few minutes per hour, or something, or just a day every few days, or something like that.
Thank you. Other questions for Haley?
I should add the other reason we have to duty cycle these is that they can't be running at the same time, because they're all like the two echo sounders are at the same frequency and the ADCP is not, but it still interferes. So another reason we can't get exactly continuous data. And I think you said that the folks from Scotland aren't on right now. But one way
we're missing several of our marine mammal people, but Caitlin. Caitlin's not in Scotland now, is she? Jason may have some insight into some of what's going on. Kara's
right.
on.
Well, I was thinking Beth Scott's group, Benjamin Williamson, and everyone. They've kind of gotten around that by actually integrating their instruments to alternate things, which gives a more continuous view from all of them, which is a really interesting idea that we should think about.
Great. Any other questions for Haley? In that case, turning it over to Gail or whoever is taking the helm here. Gail?
I'll give it a shot, but I will allow, anybody, Garrett, Haley, Aurelie can jump in on this. So the methods that we've used in Cobscook Bay, primarily around the Cobscook Bay Tidal Energy project of Ocean Renewable Power Company, started in 2009, but we did some work in 2010 using a Didson acoustic camera that's shown there on the left at a beta unit to look at fish behavior near field to a device. And I won't get into more details there because I think we're more interested in the longer term studies. So the 24-hour surveys, similar to what Aurelie was talking about, we mostly did 24-hour surveys so we could capture both day and night presence of fish and where fish are in the water column. And we did this distributed through the year. So the 24-hour surveys allowed us to have a day ebb tide, night ebb tide, day flood tide, night flood tide to do direct, at least to look at comparisons of when fish were there. And that is one thing that we consistently found, is that there is a pretty big difference, especially at this site, in terms of the numbers of fish and relative density that occurs between day and night. The other thing that when we started this project off, we were very concerned and wanted to make sure we had a control site, which actually proved to be pretty important down the road as we were looking at comparisons once a device was in the water. So again, we're using vertical distributions of fish, as you see in the lower right-hand corner. We looked at relative densities of fish off of the bottom, since that's the relative comparison for the turbine that was deployed there. And the one that's depicted there is ORPC's HiGen. And so what we wanted to do is have, here we had, again, 1 meter depth bins where we looked at the proportion of our relative densities that could be assigned to each of those depth bins as they were, could be related to the depth of particularly the turning turbine parts, which are indicated there in the red dashed lines. So the picture here just shows you a depiction of what we used. We actually used a single beam transducer, 38 and 200 kilohertz, to do this, and most of the data were analyzed with the 200 kilohertz frequency. We've done some work, and if anybody really wants to talk about it, Garrett can talk a little bit about some dB differencing that we did between the 38 and 200 kilohertz to actually distinguish and pull out the zooplankton to have mostly fish counts rather than having the zooplankton counts mixed in with that. So that's something to consider in terms of standardization. I know that we've had some discussions of what is the right frequency, so you'll notice that at the force site we're using 120 kilohertz. Here we use 38 and 200 kilohertz. The more frequencies you have, and hence going to the EK80 and the continuous wave, you could actually do some of this separation of species if you have more frequencies. So standardization might be, that would be an interesting topic. So next slide. Oh, unless you, so the other thing that we've done, and this is really Haley's dissertation work, using a stationary side-looking split beam, and it was 200 kilohertz. We looked over a multiple year period for the numbers of fish passing by a site. And we looked at two things. One, when the turbine was there but not turning. And then once the turbine was removed, we were able to use that to look at variation in fish presence over time. And there's a lot that we could go into there, but I'll leave that open. If anybody wants to talk about that, I'll let Haley address that. The third thing we did that's shown here is the mobile down-looking hydroacoustics. So we essentially did transects over the, it was actually the Ocgen at this point, so a different MHK device that ORPC had deployed. And we went with the flow and did down-looking hydroacoustics using a split beam 200 kilohertz echo sounder to look at the numbers of fish in various, again, vertical bins up from the bottom relative to the turbine itself, and developed a probability of fish encounter model that was done by Haiju Shen. And that some of the results that came out there were we were able to say approximately at what distance do we start losing, do fish maybe go out of the hydroacoustic beam and look like they're avoiding the turbine. So, well, let's go to the next slide. I think there's one more. So this is a compilation of the types of things that we've done over the years. The green box that's indicated on the far right around the turbine kind of is an indication of the acoustic, the acoustic camera did some surveys we did right near field of the device. And then we used methods to look at the yellow, depending on your screen, beams are the stationary side-looking acoustics that Haley used to look at behavior near the device. The before-after control impact studies were done using down-looking hydroacoustics, which really aren't shown here. And we used the mobile acoustics, kind of indicated by those blue arrows, to look at probability of encounter. So what is the probability that a fish is actually at the depth of a turbine as you're approaching it? And that's where the control site was very helpful in terms of a reference. And then I guess we have a little bit of interpretation of the data. So we were able to look at, and this is where, standardization is great but knowing what your question is really important. So behavior near field of the device may take a different set of standard methods versus looking at abundance over time near the device or relative to a control site. So again, these are just multiple ways that we've tried to kind of split this up and have some answers to what are fish doing around tidal energy devices. And again, some of this work, and we can go back to the thresholds and such, really informed what we ended up doing at the force site. And you can see that some of that comes out there. I guess I'll stop there.
Yeah, wonderful, Gail. Thanks. So, questions, anyone, for Gail, for her team? So those are the fish slides we have. I wonder if there's, there's questions that come to my mind, and I'm sure others have them too. And Gail, I think, really summed that up well. Obviously, the monitoring you want to do depends on the question you're asking, and therefore any kind of level of standardization has to go along with that. So I think it's fair to say we wouldn't expect to see standardization of exactly the same data collected if you're trying to look at fish interacting directly with the turbine, the potential for collision or just, quick evasion, etc., versus at some distance from the turbine where they may be avoiding or perhaps attracted, and then the third set further afield being what is really happening with the populations. So is it fair to say there really are those three separate sets of data collection envelopes, if you will, and therefore any standardization we were to look at really has to be cognizant of those? Is that a fair presumption?
I would say, and I guess before I'm just going to say one more thing, is that the question came to us at the force site was not what is happening right at the device. So that's why we went with some of these other techniques and said, okay, it's not our responsibility to say how the fish are interacting with the device. So that's why we didn't do stationary side looking, well, for other reasons as well. And then, the question became, well, midfield and, generally speaking, where are fish in that site was the question we were trying to answer. And how might that change with the addition of turbines?
And I think that, separating that out kind of by scale is one way to approach standardization, but also to point out that all of these things build on each other, and to keep in mind, we're kind of using all of these different sets of data to start looking at the bigger scale questions. So, as we standardize, we need to keep in mind that, the data sets will need to work together at some point. I don't know if that's important to...
Absolutely right, Haley, yeah. Very important point. So, let me modify what I said before. There's different, and if we were to take spatial scale, close to the turbine, a little further away, further afield, but again, not every set of data may be collected to answer every question. But Haley's point that you do need to have this sort of chain of reliable data that can interact with one another. So are there any other scales? I suppose there's the temporal scale too we should be thinking about. But in terms of spatial scale, can we mostly agree there's those three spatial scales? Any other thoughts?
Andrea, this is Jason. I don't know if this fits under the spatial scale or not, but all of the slides we've seen so far have a commonality in the sense that there's been a control area, which I guess I think of as sort of a part of the spatial scale. And I don't know if it's a standardization issue or what, but or whether it's more just sort of a best practices suggestion. But I think that's one of the issues that have been discussed in the past, and is a difficult one to nail down. I.e., what is a good spatial control for your data set? And I don't know if I'll just throw that out there, or what. I don't know if that falls into what you're talking about in terms of spatial scale, but.
That's an incredibly good point, Jason. So I guess I keep trying to sort of sliver up standardization into different means, and spatial scale is definitely one of them, and the need for a control is definitely another, whether it's spatial or whatever. What about this issue of control at the broader spatial scale? What do we feel about the fact you cannot do proper control experiments close into the turbine? Any thoughts from those of you who have been collecting fish data?
I think maybe the question isn't necessarily what is a good control. Sorry, this is Garrett at PNNL. I think you have to tackle this from what is your best control. I think depending on what your site location is, how close you can be to the turbine, how far away, the variation of habitat nearby, I think all of those are going to affect your choice of a control. But with most experimentation, I think a lot of people would agree that having a control is going to be very key in having the best one. That's, I think, where the problem lies.
I think calling it, yeah, so it's more really kind of reference than control, since we're not really controlling it. But I think to add to that is that part of the baseline work that we did was gathering data at both of these sites, and I think if we had found that they did not show the same patterns over time, then it would have been deemed not a good control site. Correct me if I'm wrong, Garrett and Gail, but I think that's part of the value in the data beforehand is being able to identify a site that does show the same trends as your site that you think is, at least outside of immediate turbine effects.
So this is Jason again. So maybe that's the important part to take out of this, is that there needs to be a broad enough spatial scale early on to decide what is your best control or reference area.
I would say that, but I'd also add that considering more than one control area is important. Garrett and Haley and I got dinged on that with some work that we're working on publishing, and somebody said, you know what, you need more than one control area. And fortunately at the foresight we have 3 transects, which I think is going to be helpful, and we can show that those are somewhat independent of one another acoustically. So I think that will work out there, but thinking about more than one, unfortunately, I know that's, everybody's rolling their eyes saying another one, but that's been something that's been brought up to us.
Yeah, so I think that feeds perfectly into, I guess, what Andrew's asking about in terms of the spatial scale is you need to be thinking about, yes. And I think that's what the mobile surveys that you guys have been doing are getting at, right, is that you have a broader spatial scale that you can then say something about the trends over space.
Right.
Space.
Yep.
And I think having some of the talk has been about needing a baseline at these sites. I think also the control site is almost more useful than a baseline in these areas, which are just really hard to predict. Any distance into the future, I think control sites are something to definitely work into future talk of standardization.
You guys are right on about that. So if we were to say a control, or I think Haley's point about it's almost more of a reference site than a true control site. If we were to say that the reference site needs to, as Gail said, show the same trends as your treatment site, your turbine site, what else do we need to be thinking about here? I wonder if, especially if you cannot do many transects and many broad surveys, I would think looking at the hydrodynamics of an area and trying to match the hydrodynamics to some extent, which provides you to a large extent the pelagic habitat, but perhaps, especially in shallower sites, you need to be looking at the benthic habitat as well. Thoughts on what those criteria ought to be for a good reference site?
Well, we definitely thought about at least having depth similar. That's one of the things we struggled with at the foresight is where those are is very close to shore, and that's somewhat purposeful because at that site we wanted the depths to be similar. So maybe the hydrodynamics would be somewhat similar, but we are on the other side of a channel, and there's certainly different hydrodynamics. So it is that's certainly a challenge. So you definitely want to think about that, and that's one of the things. Our control site in Cobscook Bay was deeper than the site where the turbine went. However, we would argue that what's happening towards the bottom in the similar, if you're actually looking at from the bottom up, the dynamics are similar. So looking at ADCP data in a site that might be similar in depth.
Mm-hmm. Good thinking. So if we talk about standardization of data collection, just for a moment, can we, what do those other slides say, Amy? I can't even remember. Yeah, go to the next one. I've been trying to think about probably trying to decree that certain instruments and exact methodologies be followed everywhere is probably not ever going to work. And at the least, we probably need to be discussing the same parameters being collected, which we know has not happened necessarily. What are those kinds of limits, though, of, collect fish density, how versus use this instrument at this frequency, in this manner? Where is that sort of sweet spot where there is the ability to compare data sets, especially from location to location, versus being extremely top-down, you must do it this way? Did that make any sense? Sorry about that. What are the sort of the tolerances for standardization that will still make data sets useful, especially if we try to bring them together or transfer them from one spot to another, versus really trying to force something that's not going to happen? Does anyone think we can decree how data should be collected as a community and make it happen, down to the exact methods and instruments?
Anna here. I don't think we're probably there yet, but maybe there's an opportunity for some experimentation to actually look at what the sort of best practices might be under different scenarios.
And by different scenarios, Anna, do you mean different questions or different locations, or?
I would, well, could be a number of those things. I would think that people would need to get together and think about that. Might be issues related to the characteristics of the site, and most certainly the instruments themselves, and also perhaps how instruments are used in combination. I don't know, I think we're just really getting into this now, and it would be, I think there'd be a really great opportunity if we could bring instruments together and experiment with different combinations to arrive at the most ideal situation for collecting data. I don't know if Gail's group has thought about that or not yet.
Which aspect are you talking about, Anna? In terms of what?
Well, I'm just thinking I guess we're really just getting started on looking at best practices around how we collect data and what sort of settings are being used to do that. And what we have is what we've tried, and I'm just wondering how much experimentation has there been. If for instance, 3 years from now, someone wanted a guidebook on how to do this, what would be the basis of preparing a guidebook for someone to do all these surveys at a new test site someplace else?
Yeah, I mean, I think you could, I like the idea of coming up with the best practices where you don't necessarily decree what instruments and specific methods are deployed, but trying to say, what parameters might be collected. And for on this slide, it's just kind of making the hair on the back of my neck stand up to ask the regulatory agencies to require standardization. Because I feel like maybe they won't have, like, I think maybe what Anna is saying is right, that, they are not going to be the ones who have done that work. So getting the research in place where you can actually come up with maybe a table of options of what could be collected using what instrumentation might be the best approach. So maybe taking some of the summarization that we've done around, for instance, that last slide we had, it's kind of a menu, right? A recipe. And then, assigning what instruments could allow you to do this. Because I feel like if the agencies say you need to use X, Y, and Z equipment to do X, Y, A, B, and C, it might be really difficult for instance, the consultant who may need to do the work or the company to get someone to actually do the work around the devices. And I'm going to stop there because, Andrea, maybe I'm off topic.
No, you're right on topic, Gail, and I agree entirely. I do not believe that we as a community, whoever that really is, can decree it must be done this way. And that's why the way I sort of phrased this question on the screen, is measuring the same parameters using well-calibrated instruments, really understanding what you're collecting, is that sufficient? And that's certainly where I lean. I wonder, listening to you guys, it sort of sounds to me, coming from other fields, that what we need is a cook-off. We do need some comparability among some of these methods, and the only way to really do that is to, measure the same thing, as it were. And we may not be there yet, but particularly as new instruments come on the market, it's really nice to know how you can interpret those your existing data in light of that. So maybe that's something to put sort of a pin in, that at some point we need to bring several of these sort of what are seeming the tried and true instruments or methodologies together and really look at them side by side.
I think that's really challenging because one of the things we didn't really bring up is that the new SIMRAD EK80 that now is being used in Canada, that may have we haven't really explored the possibilities with that piece of equipment. And I think it may actually push things forward from a more basic perspective that may benefit the industry, but we simply, even the people I know that are working with that equipment on the research side are scratching their heads a little bit. So, getting our heads together around that and how it fits in with the more standard monitoring that has been going on would be a good idea. And I think just my last 2 cents are, having a real network of collaboration around the research, I think, is going to be a huge benefit. To me, and I don't know if it seems like a monopoly, but now Garrett's over on the West Coast and Haley's up in Canada, and so we're actually interacting quite directly on how to make sure some of these things kind of work together. So more of that kind of interaction would be great, and I think is what Haley's suggesting.
That's it, Sherry. I just want to chime in here too and follow on. I think what Gail is saying, and I agree that I think it would be a mistake to make particular instruments be required, because what happens it kind of kills innovation. And that would be making the assumption that the instruments we have now are the best we'll ever have, so we're going to require that we use those. And that's, just like what Gail was saying about now the EK80, it's just starting to be explored. So I don't think that would be useful to specific information. However, I think where standardization would be appropriate is at a higher level of what are the questions that you need to answer, and to make those very clear, and that will drive, okay, to answer those questions, what is the data that we need, and then leave it open as to how you actually collect that data, but keep the standardization part at the higher level.
I agree with that. I was just going to say that actually, and I think the point there is that still allows each site to handle its own particular issues the best way, right? So at our site, acoustics might be the best, but at a shallow, clear river, you might prefer to use cameras. And I think that the questions are really the important part. I agree.
Good, really good points, guys. Great. Okay. We don't have an awful lot of time left. I'd like to make sure we cover two things at least very briefly. One that Haley just alluded to is the use of cameras. We don't have any slides, but Garrett or Sherry or Nate, do you guys want to talk a little bit about camera use and what you see in that, and whether it's a method you want to see going forward, or you hope to never see it again, or whatever?
This is Sherry. I'll just say something real quick. Just based on my limited experience working with the video, I think cameras do have a place. I think what's challenging at the moment is that there's not standardized tools for doing the analysis really easily. Just like there's the Echo View program that everybody uses, and that has all kinds of nice features for doing sonar analysis, but there's not the same sort of thing for underwater video. So that's a challenge. So it just makes the analysis more time consuming at the moment.
Great. And for anyone else on the call who don't know, what Sherry's alluding to is that ORPC has a very nice, robust, big data set of optical cameras, underwater cameras from their Igiagig site with the turbine in the river. And there's very large amount of data that our guys have been going through trying to create algorithms to really reduce those data and make them more manageable. But they are kind of having to make up some of it as they go along. Is that fair?
Right. Yeah. So that's the basis for my comment there was based on that experience with that data, and I think the video cameras will play a part in what we were talking about earlier as near field kind of interactions. I mean, because the range is going to be limited.
Great. So in the time we have left, unless anyone else wants to say anything else about fish, Jason's on the phone, Caitlin's on the phone, some of the Aquaterra folks are on the phone who are dealing more with marine mammals around turbines. And the fact that we're missing, Benjamin Williamson, Beth Scott, and Carol Sparling is too bad, but, that's the Maygen pull. Do you, Jason, or others want to say something about marine mammals in these terms of sort of standardization and equipment and whatnot?
This is Jason. I mean, I guess at the risk of making broad statements, I think a lot of the same issues, or the same issues that have been just discussed for the fish stuff, apply just as well to the marine mammal side of thing, and it boils down to, it seems like the best approach might be to try to standardize as best as possible the questions that are being asked, and then have suggestions maybe for minimum spatial and temporal coverage to answer those questions, and then leave the individual sites to try to come up with the best combination of instrumentation, whether it's active acoustics or passive acoustics, or video, or whatever instrumentation seems to work best for that site might be the most the best I think we might be able to do without constraining as Sherry was saying, constraining innovation and stuff as new technology becomes available.
Yep, absolutely right on. Okay, so last time we met, we had brainstormed a list of topics that were of interest to those involved, and that's sort of how we started talking about standardization. Assuming people are still keen to continue, I'd like to suggest if we pull this together again in another month or so, a couple of possibilities. Perhaps we ought to be focused somewhat on marine mammals, and we could talk about the standardization of those data sets. I think, as Jason said, the overall principles, if you were, are very much the same as those with the fish. Also, I think that with the Maygen array deployed in Scotland now, maybe there is the opportunity to begin to talk about monitoring around arrays, because array scale monitoring was one of the real interests. What do people think about that? Are we too early to be talking about that?
I think it'd be really interesting, but we'd have to defer to the Maygen folks who are involved there to see whether they think they're ready to discuss it or not yet.
Absolutely, yeah, absolutely. Okay, well, and I will reach out to them and check that. Jason, what's your sense on sort of standardization of the questions of standardization of data from the marine mammal monitoring perspective? Worth sharing more online like this? Oh dear. I hope no one has to evacuate.
Was that a marine mammal?
I think so. Yes. Mid-range whale.
The main we have a noontime bell, believe it or not.
Okay.
Yeah, I mean, I certainly, would be happy to share some of the stuff that we've been doing on marine mammals, as could many others. But I do think that, we're going to get to the same place where I think we've kind of gotten with for the fish.
Okay.
So maybe the next one of the next seminars might be to try to coalesce around an agreement, or trying to reach agreement on what those questions are, and what sort of spatial and temporal coverage are needed to adequately, or at a minimum, answer those questions. That's just my opinion. Hopefully others will have an opinion too.
That's actually a great idea, Jason. What do others think of that? Maybe follow up with trying to take the next step from the standardization, if not pin down the exact questions, start to bin them a little further, and see where that relates to things like reference sites, and how far, as I think it was Gail said, sort of a menu, where you might have a menu of options of ways to measure each of those questions, answer each of those questions.
I think getting to those questions, the other thing that's been intriguing to me, and I don't know if Nate is still on here, but I'm going to be involved with fish and marine mammals next time we get in the water. So I think we need to be thinking about across these groups, and thinking more about how can we do these things, because typically the fish data are collected using active acoustics, and the mammal data is collected using passive acoustics, and they don't really, you have to duty cycle, there are all kinds of other issues. So if we could standardize the questions that we're asking somehow across groups, that would be even more interesting.
Wow, I think that's a great idea.
Well, let's see if we can put that together then. Okay, and I will reach out to our Maygen marine mammal people, and I'm sure you'll be talking with them as well, Jason. And maybe they'll have some greater insight there. All right. Well, I've been scribbling notes on where I think we were trying to sort of coalesce around, and I will get those out. And we'll try and set up a date to continue this discussion. Thank you very much for participating.
Thank you, Andrea.
Thank you.
Thanks a lot.
Thanks, Andrea.
Bye-bye.
Thank you.